Well then, the equation that we had found was this. This is the equation. And here we have some variables, for example, that what was N was the amount of molecules, quantity of molecules. We also have variables like the R, well, L. Usually one seeks to report the square R of the regression and the square R for the QSAR model to be good. It has to ideally be greater than 0. 8K. Eternal and C. That's a hard there. A good QSAR has a R squared greater than 0. 8. What is this? That follows the standard deviation. The standard deviation, therefore, when are we going to have a residual? We had said that a residual is equal to 3 times, is greater or equal to 3 times the standard deviation. Then a residual in this case greater than 3 times the standard deviation, that would be 3 times 0. 194, we are going to calculate how much is that. And that would be 0. 582, 0, E. 582 means then that the difference between the two, 0. 582, 0, 582 means then that the difference between the biological activity minus the predicted activity, if it gives higher this value, we talk about a residual, then we go back to our table where we had all the information and her. We have then the observed activity minus the calculated activity. This is how a residual is calculated. Here is the information that it was a residual, or delta is the experimental activity minus the predicted activity, and this has to be less than 3 times the standard deviation. If it gives higher, it is a residual. Notice that the criterion of 3 times the standard deviation, in this case, was stricter than simply saying less than 1 because it gave 0. 582. Where do you see the greatest difference, the greatest deviation in the prediction? Are all very good predictions. 4. Clear a little less we are going to calculate then. That 1, because the others look quite good, it seems to me, which is 928 to 935. It is close, of course. It is close. And then this would be clear, for example. This here, then, we are going to calculate the residual to the composition 21, then the residual. Would be experimental activity, the observed activity 9. 3 exactly to give negative minus 0, 23. The cocktail, I'm tasting capsule of vitamin D. Well, then we go already. Thanks 7, and thanks 746 minus 7 tor E, 82n. Let's confirm quickly. Minus 0.1. We already have then these two residual values of the negative 36 and minus 0, 23, and according to what we had calculated, clear the limit is 0. 582 then, in both cases we are inside. That is to say, that there are no outliers. There are no outliers. There are no atypical values. We are within the margin. All the predictions are good. That then you have to always calculate. See, which are the outliers compounds, the compounds that are outside of the predictability of the model. That is an outlier compound. There are other methods to detect outliers. We will see them when we see the practical part. Of this that are the following, I am going to insert information here. We can easily detect biological outliers. Through what is called a Williams graph. And we can detect structural outliers. With what is called the calculation of the Tanimoto index. We can detect that the compounds of the biological activity are so far away, and that the compounds of the structural similarity are so far away with most of the set that is being studied, because the question that arises is, can we make a QSAR mixing any type of molecule? Or at least they have to look like something. The answer is, there has to be a certain resemblance. Okay, we return here to our results, and we have that finally another value appears. The value says the F at a higher value better. But this value makes sense when we compare two models. The model that has the largest F value is better. It is a more reliable model. At a higher value of F a feature, the model is more reliable. And at this point, the question arises, they are only those, all the metrics that a QSAR model has to be calculated. No, they are not all those the metrics that we have to calculate at QSAR. We have to calculate S. And there are other metrics that we are going to see in the practical workshop. Okay. The table that is down here is another way to represent the free Wilson equation. As representing the equation in this very long way, we can represent the results in a table. Example says here, fluorine meta, fluorine position, meta minus 0, 3. There is the value in fluorine for 0.34. Let's look for it here. It is fluorine for the coefficient is 0.34. Then we can represent the results in the form of a table, and it must be said that the intercept is 7.82. There is the intercept, that is this one here, 7.82. Then, looking at the table, then we return to the question. The best combination would be to have Yodo in position meta, because we have the highest coefficient and Yodo in position for who follows. What would be the second alternative? On the right for OK, the metal in para is the value that follows him very well. Also, not true, 0.45 with metal in position. Meta, there. A second molecule with Yodo. To see, remember, methyl in clear, good observation, not true. If we can, of course, that the second best molecule, thanks for the observation, to see the second best molecule, then it would be changing, leaving the Yodo pattern. And an OK. It follows then, after this value of 103 comes 126 for methyl, and we can now combine with Yodo in position meta. And the rest. This would be another molecule proposed. The question is, this molecule was on the table. Our 22 molecules, we return to the table. Here are all the fragments then. It was metal in para, OK, then methyl in para. Here, there is one, but it is not because I have metal and bromometal. Then it does not exist. We are proposing a new, and therefore we can predict the biological activity, and it is equal to the PNC50. It would be equal to methyl in position para is 126. Ganini count tinder change gun tompel tompi practi. Thanks 0. Ein. Next is 0%. And 0, 58. We quickly calculate. Thank you, 9. 66. That is the value of PNC 50. Then we are going to go now to what would be the value of IC 50. Well, the value of PNC 50 means that the least logarithm of the IC 50 is equal to 9. 66. Then the IC 50 is equal to 10 raised to minus 9, or 66. Eu, ta, eu, kaiti, 19 thanks for 10, raised to minus 10. That is, in other words, that if nano is equal to 10, it would be exactly 0. 219 nanomolar, very well. That would then be the value of the IC50. This is the IC50, OK, 0. 2 nanomolar, that is, it is an extremely compound, or it would be, according to the prediction, a highly active compound as an anti-adrenergic agent is a very good prediction. 0. 22 nanomolar is something quite promising. That is, it would be worth venturing to synthesize this molecule, and then we have a good prediction, and therefore it is worth synthesizing it well. Having said this, now we are going to introduce ourselves in the Hanchik equations. And for that, we have to understand first, what is the Hammett's descriptor there? We have Hammett, physical organic chemist, of the time one of the founders of this concept, the word. Concept of physical organic chemistry or physical organic chemistry, one of the Hammett's postulates is that the inductive, electronic, and resonance effects of a set of substitutes in different organic reactions should be signed. Well, we are going to approach the concept of Hammett's constant. And for that, we are going to study the dissociation of benzoic acid. Well, benzoic acid is an acid that releases a proton in the middle of aqueous, then is a process of ionization in the middle of aqueous in the middle of aqueous benzoic acid is able to deliver a proton to water at 25 degrees Celsius. When the acid is more acidic when it stops, or in meta, I have an electrode or electrode attractor. When the acid is more acid, with an electrode attractor, or with an electrode in meta, or in para. Yes, exactly, with an electrode attractor, the acidity increases. It ionizes more easily and therefore becomes more acidic. That is, the value of the constant increases or decreases. The value of the constant will increase because we have more product and reactant. Well, the constant for this process, if we consider that we are starting from an acid that generates a proton and generates an A, the constant Nt of the process is K equal proton by A divided by Ha. This is the constant. Then notice what we are going to do, or the general idea of Hammond's postulate. We are going to hear of Hammond. We have this. How can we know if a group is an electrode or an electrode attractor? Indirectly. Well, what is this? This says here is the logarithm of the dissociation constant when there is a substitute X in the structure I. There in meta or in para. Because never in an ortho position. Because when we have a substitute in an ortho position, the hysterical effects are important and alter the value of the constant. We want to see only the electrodynamic effect. And it is better to have an attractor. Yes, because an attractor increases the acidity. If that is what I am looking for, then how much the acidity increases we can quantify it with this mathematical correlation. That T is what we are going to quantify, how much the acidity increases when there is a group X logarithm of the constant, when there is an X divided by the constant, when there is nothing, that is when there is hydrogen. This is it. A constant value is the constant of the benzoic acid, is the constant of the benzoic acid. If we applied the logarithm directly to the coefficient, the logarithm of a coefficient is the logarithm of the subtraction logarithm of case x minus logarithm of kh, and that will give us a value when we make this equilibrium in the middle of a pit. We have that this raw value is always worth 1 when there is water in the middle. That value is worth 1. 1. In the subtraction, log kx minus log kh will give us a value sigma, and there then the definition of what is the constant of Hammett, that value sigma, and there then the constant of the substitute of Hammett, that is what in T rests us the sigma that there is, because the rho will always be worth 1. Then the sigma x is the constant of the substitute of Hammett. If the benzoic acid is our reference system to be able to estimate this empirically back ours today, one can also calculate it, but one wants to have the empirical result. Then it is necessary to occupy benzoic acid, and all the groups are put there. Of course, one can try an infinity of groups connected to benzoic acid in para and in meta. The value will be different if the group is connected in para or in meta, and there are groups that it is not possible to connect chemically, and of course, very reactive groups it could make that. If we connect, for example, a group like a chloride of acid that would be difficult to measure with this method because it is very reactive. It will decompose in the water, so there are groups that could not connect. Then the px is because there are reactions that cannot be carried out. Of course, exactly very well, if that is worth the rob. Not true, the rob exists, because there are reactions that cannot be carried out in the middle of things. Of course, you can measure in another solvent, such as emitting seawater. Alphoxide, for example, it is exact. That is, that rob takes another value in another solvent. It adjusts according to the solvent. Yes, how would we distinguish because the income is not worth a result? How do we distinguish which part of this result is because the rob values are tabulated? Of course, if in the next session I can bring tabulated values taught, I have in a book so that you can see that we can graph this. That is, if you realize it, note the following, look at this equation. If we adapt it a little and move what we have here, I am going to move that t is this log kx. I am going to throw it to the other side and notice the following. Look at what happens. Let's say log kx equals rho sigma plus log. This is an equation of the type y equal to x plus b, so one can graph this type of equations, and when the slope would be exactly then, this x is sigma very well. The y is log kx, and when one works in water, when exactly the slope is worth 1, such as the points are adjusted here to a line. Not true with a slope, with a roll in this case, with a roll equal to 1, when you work in water, always the graph gives with a slope 1, that is because there it comes. But when one changes the solvent, the line moves okay, perfect. Then we can now return to our point to finish here. The idea, and this is the question that I am going to ask you now. Sigma sub x can be positive or can be negative. What does it mean in each case? Then, based on the reasoning that we have just done, if it is positive, it means that group X is the attractor group. X is the attractor group. But if it is negative, the X group is the donor electrode or electrode. They are different things. The attractor, electrode, then example. Example. Because if the positive subtraction means that the log kx is greater than the log kh8, then suppose example, if it is positive, that implies that log kx is greater than the kx question. That could be, for example, the effect of a nitro group. Is a nitro group connected to the benzene an electrode attractor? Yes. So a nitro group could be the one that causes this effect. A nitro group has a positive sigma value. So the conclusion of this is that the nitro group is a positive sigma value. On the contrary, if it is negative, that means that the log kx is less than the log k sub h. Example, an alcohol group, an O group has a negative sigma. because an O group is an electrode and therefore decreases the acidity of the ionization constant then. That is the underlying concept of the Hammett constant. What I want you to want with this is that the Hammett constant allows you to know if a group is an electrode or an electrode attractor. We can measure that today in other ways. If you can measure in a theoretical way, however, there are many tables with all these tabulated values, but we can also measure them theoretically. Well, here we have this website. We can calculate the sigma descriptor of Hammett. Then example says here, draw the substitute and mark its connection using the atom R, then press calculate. OK. Then the substitute that we want to predict was a nitro group. Then a nitro group has oxygen, oxygen, nitrogen. And here it would be connected to the rest of the benzoic acid. Then to the nitro group, we are going to calculate its property. Here it's sigma positive. In position meta 0, 77 in position. Para 0 potential, perhaps in potential 98. And it also gives a pi value of hash that I will explain later. And the question that arises is why the sigma value in position para is greater than the sigma value in position meta. Exactly, and by resonance, it is better attractor in position para than in position meta. Very well, let's calculate for the alcohol that we had just written. If we have an alcohol, it should give negative in meta. It gives close to 0. That is, its contribution is not very significant, but in para it is negative, because in para it manages to make resonance with the carboxylate, increasing its electronic density, and in meta its value is close to 0. That is, there is practically no electric contribution in meta because the resonance is not conjugated with the carboxyl in position meta. Then that is the explanation of why W, A have different values, in meta and in para. Well, then here are several tabulated values. Equation of Hammett. Here we have the value of sigma in position para, sigma in position meta for different substitutes. Then we already know what the sign means. If the value is positive, it is an electric attractor, and if the negative value is an electrode. Well then, from here, from this table, let's see only the effect in position para. What is the most electric attractor group in the series? Perfect. If we go here to the positive values, non means hydrogen is the reference when there is no substitute. Then, from here, the positive values start, if very well nitro. And what is the most electric attractor? The opposite. Amine to see very well, then dimethylamine. That is, so anchor 3 connected to the RK. Then here comes a question, why a simple amine was not as good as dimethylamine? Because dimethylamine is more electrostatic than the amine that has nothing. What is the difference? Of course, the values. Sure, the contribution made by the metals, not certain by inductive effect. Then we have the resonance effect that can be amine, plus the inductive effect that the metals groups can do simultaneously here. I have only the resonance, but not the inductive effect perfect now. In the position meta, which would be the most electric attractor. Okay, also nitro very well, and the most also yes, perfect wins in the two positions in the same groups very well. And then there is certain correlation in that sense then. From a table we can obtain values. We can take them out of the website that we have just seen or with our dkit. Very well not true in throwing some lines of code in Python. Well, in the same way that Hammett raised, what was sigma now Hans defines? What is a value of pi? Is the lipophilic constant of a fragment T? That is, we can calculate the lipophilia of the entire molecule. Yes, but what was the contribution of Hans said? Why not calculate the lipophilia of a fragment? Only then the question is how I calculate the lipophilia of a F. Fragment, the answer is calculate the P of the entire molecule with the substitute X then. Here is our chlorine. That chlorine is the substitute X. Calculate the lipophilia of the entire molecule minus the molecule when it do. S note have the substitute X. That is when there is hydrogen. That difference then gives us pi, which would be the lipophilia of this fragment. The lipophilic contribution of a very interesting fragment. This concept and here. Again, the question arises what happens if this difference is positive, and what happens if it is negative, and as a reference. But you can also use the acrylic chain. That is, you can have the pi depending on the system. And taught you are measuring today and tables for everything, and so I assume that the same pi exactly changes, and there we are going to see a concrete example that I am going to ask you why it changes. Ask if the pi is positive. If pi is positive, it means that if pi is positive, that implies that log px is greater than log p. When there is nothing, then the substitute contributes or subtracts lipophilia very well, a pi positive. Any means that the fragment is lipophilic. And if it is negative, the opposite, the fragment is hydrophilic. That would be the difference if a substitute has a negative pi is contributing hydrophilia. If a substitute has a positive pi, the substitute is contributing lipophilia. Very well with that, then, in mind. As notice here in he table it says, group substitute not true with its pi value, but substitute connected to an aliphatic system. And here substitute connected, but to an aromatic system. Then there's a certain correlation, and I leave some exceptions that they are going to be asked. But there is a certain correlation then in general terms in the case of the substitutes connected to the aliphatic system WW. He is the one that contributes the most lipophilia well. I'm going to see the one that contributes the most lipophilia 168. If the most positive is that. Okay, then tergutilo is one of the groups that most lipophilia contributes. and terbutyl contributes the same aromatic lipophilia, the same 168, and it is the most lipophilic. Then a terbutyl group contributes a lot of lipophilia, contributes more lipophilia than an halogen, which contributes more fluorochlorobromine, contributes more 6 and 86 in an aromatic system. And then here I have some questions, but vice versa. Which is the one that contributes the most hydrophilia? Perfect. Then the most negative would already be alcohol, very well. Or H is the one that most hydrophilia contributes more solubility in water. And then we can play now with lipophilia, changing the fragments in particular positions. And there are two questions. Why, when there is a methoxy group, we have this variation now from a purist point of view when something is close to zero. This means that it is a fairly despicable contribution in reality, or that it is a contribution close to zero. But it is worth giving a small explanation why this happened. And it's because the methoxy, when we are connected to an aliphatic system, and how if out there goes the thing, that is what happens. A little simpler when one has an aliphatic system. When one has an aliphatic system, the methoxy group, as all ether, contributes to lipophilia. The ethers always contribute to lipophilia. The oxygen of an ether is quite lipophilic. We have already explained it in past classes. But there is a variation when it connects to a benzene. Its pi value now tends to 0 because it can be polarized more. By resonance then, if it is polarized more, that oxygen will be a little more delta positive. Then it will have a greater polarization, and that is why its pi value tends to 0, okay, because it contrasts having one more carbol. And in the structure with the extra polarization that this adds to the benzene ring. On the other hand, second question in this, we are going to end the session, that example of the fluor. Remember that this up here is aliphatic. Say, then this would be aliphatic when I have an aliphatic chain, because it is fluor when it is in an aliphatic chain gives a negative value, but when it is in an aromatic system, it gives a positive value. And there are quite opposed to the resonance that fluor can do. Is bad fluor is a bad resonant agent. The fluor resonance is very poor because it is very electronegative. The difference is that here we have a sp3 carbon and here a sp2 carbon. The electronegativity of a sp2 carbon is greater than the electronegativity of a sp3 carbon. Therefore, ask where the system is more polarized. Here, we have a much greater polarization, much stronger, very well, because it is not true that the fluor can better attract electrons and generate there a delta plus, because there is a sp3 carbon here, a sp2 carbon. Then it costs more to generate the polarization. The polarization is smaller. That is the reason why we have that difference in the contribution if we are in an aliphatic chain or if we are in an aromatic ring.